Hi, Joe Glavin at City Floor Supply. Thanks for joining us. Today I'm in our repair shop for equipment, and we're going to go over the Hummel motor, and we're going to open up the top here and get inside, take a look at the capacitors, the switch, the universal contactor, fuses, all the good stuff that's in there. Possibly help you with a field repair. I have hanging here on our cherry picker. This is an American 8 American 8 motor. Similar to this head here, has many of the same components in it that the Hummel motor has in it. We won't be working on this one today, but we will get into taking out capacitors in the Hummel motor. Kind of go over a little bit of what a starting capacitor is, what a running capacitor is, the fuses, the contactor, just in general what goes on inside there, and then a change out the safety protection switch. So I know we had some difficulty earlier. We're a little late getting started. I think we had some connection issues. So we're going to go ahead. I'm going to take this motor off. So anyone that's not familiar with taking a motor apart, if you're working by yourself, you probably already know this because you're taking it apart to get it into the job site. But you're going to take this safety protection switch off here. You're going to open up the side. You're going to need an Allen wrench. That should be in your toolkit. And then take off your fan belt and your drum belt, V-belts. We're going to loosen up these knobs here, and you're also going to loosen up this eye bolt, and that'll help you get the V-belts off. Then the motor should just pull right out of it, just like that. This is an emergency stop or safety protection switch that ships with the Hummel. I'm just going to get a block to set this up on. All right. So, turn this so you guys can see it. Might be better if I don't have this on there. Is that better?
Yeah.
It's like that?
Yeah.
So this is a capacitor start and run motor. It's 220 volts, and it is fused. So you should get inside here. Maybe not. Torx head. Yeah, it's a Torx head screw. So yeah. So while I'm kind of taking this off, I do want to offer some caution. This is 220 volts. Obviously you want to make sure that this unit's unplugged. If you aren't comfortable around electric, I mean, this is really just emergency job site kind of repairs. There are things in here that can hurt you. We have a start capacitor and a run capacitor, and this start capacitor, you'll see, has this diode on it, and that is a diffuser, which will take up any charge that's stored in the starting capacitor so that it doesn't shock you. Or our mechanics here that are repairing these. So this is really important. You want to short this unit, this start capacitor. Start capacitor is on the bottom when you're looking from the front of the machine inside the box. It's also marked as 130 microfarads. So you'll see on here, and we'll get a good close-up of this. This is a start capacitor, and microfarads, 130, where are you? I'm on, there it is. So it says 130, and that little U is microfarads. And typically a start capacitor has a plus or minus 10%, and I'm gonna bring that over here, and it's right there, 130 microfarads. So that's the symbol for micro, and we have a plus or minus 10%. So when we take a reading on these and we use a capacitance meter, typically the run capacitors and start capacitors, one has electrolytic fluid in it, the other one doesn't. And some of these are designed so that they will swell at the top to disconnect the wiring that's inside here, so that you don't get a blown top or bulged out the sides. Now, not to say that that can't happen, but and then it won't let you run the machine. So if you see electrolytic fluid, it's like a clear fluid. Sometimes it'll pick up sawdust or any of your wood dust and lay down in the bottom of the top of the box here. You'll see it it may even look green, but it's so that electrolytic fluid, if you see that at the bottom of your motor, that means your capacitor is shot. And you correct me if I'm wrong, but I think it's the run capacitor is solid material, polypropylene, and the start capacitor actually has the electrolytic fluid in it. I might have that reversed, I forget. But either way, if you see that in the bottom of your motor, one of these is bad, and that's not good. So what do capacitors do? Capacitors take the current and they do a couple things with it. They make it even. Start capacitors store a charge so that you can start and stop the motor all of the time constantly, and you get up to full torque and about 70% of the RPMs that the machine's going to run at. That's what a start capacitor does. And there's switching in here that tells the motor when to switch from the starting capacitor to the running capacitor. When we get to the running capacitor, what we're doing is we're changing the phase of the winding to the running winding. Do we have any open motors with end bells off? Any motor? No, it's okay. Where the winding that the starting capacitor activates and runs and creates the rotating magnetic field is usually smaller gauge wire, and it's just instant startup. Once you get into the running winding, it's a heavier gauge wire. It takes more of the load. The reason that that's it, I think, the running capacitor doesn't use electrolytic fluid is because this is running constantly. This is in the cycle constantly. And this is creating a magnetic field, a rotating magnetic field with the starting winding. So you get that repulsion induction. What's happening inside here is you're getting a north-south field as this is spinning, and it's doing it on a 60 hertz cycle, which is what's coming through here voltage wise, and it's doing it at 3,000 RPMs, so, or more. And so these are pretty important components. Not that you need to know what all of that is, I just need you to know that, like, if you go to the electric store and pick up the wrong capacitance rating, your motor won't run properly. So if you have a run capacitors are typically lower numbers, and that is the capacitance number. For instance, in the Hummel, it's 40 microfarads. So if we have a run capacitor that is the wrong microfarad, our motor has a potential to run erratically. We can, again, what it's supposed to do, it's going to kind of clean up the current coming in, make it uniform, and then make that rotating magnetic field happen. If you have the wrong capacitance capacitor, then that could give you either hesitation or stop and start over the cycle of that motor. So it could vibrate, it could have loud sounds, it could just make the machine run poorly and inefficiently. You could have current draw that is high, low, all over the map. That also is a good indicator of a unit going bad. A capacitor can go bad. We can, in the shop, we have pretty hefty fluke meters. We check voltage, amperage, resistance in ohms. We check capacitance with these. So I'm going to dial this into capacitance, and then I'm going to clip these guys on, and I'm going to show you that this is 40 microfarads, and what a meter will show. Let's see if I can get this. Yeah, I think so.
Raul says hello from Ram Flooring LLC in Chicago.
Nice. Hello, Raul. So you can see at a plus or minus 10%, our capacitor is rated for 40. This is a brand new capacitor off the shelf. And we're reading 39.3. So well within spec. You could get a capacitor that will be off spec, and typically age will do that. If you're in environments where the voltage is always off, that means like it's low and you're not running a booster. These European wound motors really do want to run on 230 to 240 volts. We have American wound motors that would run on 208. American voltage in some areas is still in that 208 range. Not so much anymore, but if you get into older sections of city like Philadelphia, by the way, Eagles, Super Bowl champs. So poor voltage often can affect the capacitor. The starting capacitor, if a starting capacitor or the running capacitor fails, and remember I was telling you about the size of the winding, the gauge of the wire in the winding. If the running capacitor fails and the machine can't push over to the starting capacitor, or from the starting capacitor to the run capacitor, it'll want to run on the starting winding, and that's almost like single phasing a three-phase motor, meaning you're gonna burn up that part of the winding. So again, these guys are important, and this starting capacitor, you can see they look almost identical, right? They have the same leads going in, the same mount. So it's really critical that the 130 microfarad go in the proper spot for the starting capacitor, and that the 40 microfarad go into the proper spot for the running capacitor. Is there a question?
No.
Oh, okay. So if you are going to check these, before you check them, you need to disconnect the wires, and before you disconnect the wires, you should short the unit. The starting capacitor has any current or any voltage in it. it can be up into the thousands of voltage, but with very, very small amperage, like milliamps. So what we'll do is short it, and I just cross the two. Again, I'm doing with the screwdriver what I would normally do with this resistor and dissipate the charge. So if it's holding a charge when you do it and it's mounted into your machine, it's gonna pop like a firecracker, and it may even arc. So, but that's a good thing. If you're working in here, I always work with one hand while I dissipate any of the charge, as opposed to two hands, so I don't become the circuit. Again, if you're not comfortable going in here, don't. This is really just a field fix for those guys that really need to finish up a job and get going again. It wouldn't hurt for you to have these, in your van or in your toolbox, just to have them. So, very simple. I'm just gonna use these needle nose and create a short in case this resistor is bad. So we're good there, and I will just pop this off so that I do it again, and I've got nothing. So this is not holding a charge. I'll just put that back on there for safety. And what I did take off when I took the lid off was a grounding line. So this is ground. I'll put that back on when I put the lid back on the box. So any questions about capacitors? Is anybody, yeah, go ahead.
Raul asked, do they hold a charge?
They do. They won't if the resistor is on there. And typically the winding will take up some of the charge from the running capacitor, but I would short that as well. I just don't mess around, and I'm just speaking from experience. I've burned 2 holes in my fingers when I forgot to short it out. It'll give you a goose, and it's just not fun. So yes, these do hold a charge. These do not. The contactor or the switch or these fuses, but the capacitors do, and that's their function, right? Like the starting capacitor is sending the system over to the running capacitor, but its main job is to get this motor full torque up to speed about typically about 75 to 80% of its normal RPM is what happens, and it happens instantly. When you start these machines up, that's why we have a start switch that has several stages to it. This is engaging the starting winding. When we get it up to speed, we let it go. And I'm going to talk about the switch and that spring mechanism and how important that is, that if the spring fails, that you should definitely replace the switch. So we're going to go back to off. And it's momentary over here, which is why we use a starting capacitor when we're testing to see if our belts are tracking. The starting capacitor, again, allows for the current to be conditioned so that our rotating magnet, that starting winding is allowed to create, is momentary. But it's instantaneous in momentary. This should not be prolonged, or you will burn out the capacitor and eventually the starting winding. Good on capacitors. So taking off the capacitor, pretty easy. Adjustable wrench.
Ryan Burns asks, how long do they hold a charge?
Until they're shorted or re-engaged to start the motor again.
So electricity would just stay in there perpetually?
It'll just stay charged in there, yep. Until the capacitor fails. If the capacitor fails or is failing, it will dissipate over time. But the way that this is constructed is is to hold it indefinitely, until it's shorted out or used to start the motor. Cool. These are metric. You're going to have a hard time finding that nut and lock washer, so don't lose it. I did short this out, but I'm going to check it again. And what I normally do is pop that guy off, bring it up. And once we clear, we've got, I don't know if you can see those two wires there. There's now on my motor, and don't go by wire color on your motors. I would mark it if you're not familiar, or do things one at a time. I've always marked wires, numbered them according to where they're located on the switch and how they're labeled on the switch here. But take one off at a time if you're more comfortable that way, and put it on the new one, and then take the other one off and put it on the new one if your wires are long enough. These are pretty short, so I'm not going to be able to do that, but it's just good habit. It's probably not going to matter which pole these are on, but it will on the run. So just good habit to know that if I double mark this one with 2 dots, that I'll double mark this pole with 2 dots, and I'll just match it up on my starting capacitor here before I put it in, with the label out. Just good practices, right? And then that makes it safe. So these little rubber spacers here, they're to keep it from vibrating inside your box. If you don't have these, it's not the end of the world. The motor mounting stem here and the bolt or the nut are going to be plenty. This is really just to keep it, additional securing. You could use foam, you could use whatever you're comfortable with. So that's out. We could replace those wires pretty easily. We could put in our new capacitor. And again, the new ones come with the nut and the lock washer already attached. So while I have this out, I want you to take a look at this. I call it a universal contactor. I don't know what the current term is for it. Universal contactor. Essentially what this does is this pulls voltage from the line. While I use terms like line, I'm talking about the incoming voltage from the line. So line voltage coming in, we tap off of the line voltage in order to get this engaged. There's a magnetic coil in there. To be honest with you, I forget if is it pulling 220 off of that, or is it pulling 110? Mark? Is it pulling 220? It's a 220 coil. So there's a 220 coil inside the contactor. And you will see these go bad. And how do you know that these are going bad? When you start and turn the switch over, this will engage, boom, and shoot down. When it does that and starts chattering like this, that coil in there is toast. So we have seen motors come in where the top was taken off and a piece of wood jammed in here to keep that engaged so that whenever you turn the motor on, it started. There's a problem with that, and there's a reason that this went bad, and it's probably something more happening in the motor or in this system that made this go bad. So by overriding this, you're just furthering the damage. If this is chattering, just you're going to have to get this repaired. If this goes bad, you should get this to a motor shop. Things are going to start melting down underneath here. It's kind of where all of the outside systems come in, fuses, safety switches, all of that stuff. So if this is failing or has failed, then I mean, you can replace this. They actually made it a little bit easier. You used to have to take this apart, take this motor head off and take bolts out from underneath, but now they put it on this nice little DIN rail so that it slides on. I can show you that. So it's a nice, they call it a DIN, I call it a DIN rail. I don't know if that's a Philly term or not, but so this just slides in. And this will slide on top of the existing rail. So it's not like you have to install this rail. Yeah, there's a clip in the back here that it'll hook into. So this rail, you can use the existing rail, that, but this does come with it. And yeah, it is 115, 200, 230, or 460. So it's also for 3-phase as well. So in the field, if again, switch or this, but I'm going to talk about the switch in a minute. The universal contactor goes bad, I would get it to a shop. So running capacitor, we did talk about the running capacitor. A little trickier to get out. We've got our safety stop, emergency stop switch connected in here. So this piece here goes in here, and essentially it just engages a circuit. So when this is closed or open, the machine shuts off. When it's closed, it allows the motor current to pass through where it's going to pass through, or voltage to pass through where it's going to pass through. So it's just a open or closed spring-loaded switch. But they do go bad because everybody stops their machine with this. So I would suggest shutting your machine off down here, because this spring system is what it's supposed to do. This is for emergencies only. So I know if you're tired at the end of the day, shut the machine off, go home. But this will break over time quicker than the switch spring system will. So that emergency stop switch is wired on the outside of the motor head here, comes in, goes to the two sides of the universal contactor. Once contact is made, voltage flows through the system where it's supposed to. If this is disengaged, motor will not start. It's just designed into the motor. The motor will not start without that engaged. So the fuses, there are two. Are they still 6 1/4 amps? Yeah, 6 amps, 6 1/4 amp fuses. We call them bus fuses, busman fuses. So these fuses, so the motor is fused. It's a safety for high current draw. The way these are wired into the system, I rarely see a failed fuse. And it just comes out. We can check continuity on these, and that's how you check a fuse, is you just check continuity. Let's see. So you hear that? So that just tells me that there's flow through, which means the bus part of the fuse isn't blown apart. If it was blown apart, I wouldn't get any flow through it, and I wouldn't get a signal, audible signal like that. So again, very simple, replace the fuse. What I have seen, not to say that it's never been a fuse, but I have seen dust, and you can see the dust around this motor. This motor actually just came in for repair, or actually this machine came in for repair. But you can see the dust around this fuse holder, and what happens is dust will get down inside there and get packed in right down in here in that metal. Right. Can you see that? Hard to see. Okay, this is supposed to make contact with that. When I put this in, it's spring loaded. If that doesn't make that contact, the motor won't start. And a lot of people say, oh, my fuse is bad. Well, it's really not the fuse, it's the debris down in the bottom. So you just blow it out and reinstall it, particularly if your fuses show that they're good. So let's get to this switch. It's a pretty complicated switch, and I'm not sure that it's really a field fix, to be honest with you. But it's good to identify it in the field. You could say what's wrong with it. There. There we go. So for the switch, almost all of these motor boxes come with some sort of blueprinting, wiring diagram or circuit diagram, and this half is in German and that half is in English. So do you need to be able to read all of this? No. What I will tell you are the most common failures for this switch, and do realize that this nomenclature on here changes as the motor models have changed. So in the 30 years or more that the Hummel has been imported into the United States, they've had several versions of this motor and this switch. So you may see the number 2 wire in a different position than the number 3 wire or the C wire, or so all of these numbers, while they may be on your switch, may be in a different spot. Put them in the spot that they are on for your motor. If that doesn't make any sense, just call us. But R and N have always remained the same. This is power in. So this is line voltage in. Coming in from here, it goes to R and N. And R and N are stacked like they are here on the side here. So the switch is substantial. I've taken these apart before. If we see splash marks, we have a bad switch? If we see any splash marks, and I'm going to show you what a splash mark looks like, it really is just severe arcing around here. It's 9 times out of 10 the switch is bad. So this is a bad switch, and you can see the arcing here. This is what we call a splash mark. It's burned, and that material, so this switch is bad, and hence it's why it was removed. I think I even see some residue of electrolytic oil on here, so there's probably a bad capacitor too. I'm just seeing debris here that's kind of pasty, so there's probably an exploded capacitor in here. Yeah, you see how it's wet there? So that's probably electrolytic fluid. Capacitors were bad too. It happens. Why it happened, I don't know. But when changing out this switch, there's a screw down in here. Thought I had a Phillips head here. Small Phillips. Cool. Thank you. So we take our toggle off, and our toggle is always going to go to 0. So we take our toggle off, we pop off our nameplate cap, which is just a snap lock on there. And then we feed the unit through, and it's bolted here in every corner, here and here. Now, if you're changing this in the field, it's going to be a long day. My recommendation is to bring it into a repair shop. And I don't say that just to say it. I mean, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 13 wires going into this switch. And they all need to go in the spot that they're supposed to be in, because this switch is creating connections that are past to start, back to run, or start only, back to not off. If the machine blows a breaker, this switch and the system is designed not to restart when the breaker is reset. This disengages, and you have to come back and manually start the machine again. It's a safety feature, so that if you forget to lift the lever on your sander, you go and reset the breaker that you popped, that the machine doesn't take across and slam into the wall. So it's a safety. All of these wires, when I change out one of these switches, I'll remove one side, make sure they're all labeled properly, so that I have my O2, 2, 3, C11 and O1 on one side. Make sure they're all labeled. All of those wires are coming out of the motor, through the motor casting, into the box. So it's really important that those wires are, one, labeled correctly, and two, go back onto the switch in the spot that they're supposed to be on. We want to make connections and contacts where they're supposed to be and not where they're not supposed to be. That's a surefire way of something going poof. So then I usually do the other side, and now I have my wires out and labeled, and then I take my new switch, I put in my wires on one side, flip it over, put my bottom wires in, reinstall the switch, cap it off on the side. So that is just a brief, in our shop here, it can take more than 30 to 40 minutes to install this switch, just to make sure all the wiring is correct. In the field, someone that's never done it before, you could plan on being over an hour. So, but if this switch goes bad, there's a reason for it, and it's probably because there's something else bad in the system, whether that's a capacitor start or run, or the contactor is bad, or you have a poor system, feeding system, that is line in is bad. Something coming in is low voltage, and you need to fix that with a power booster or something that's going to clean up that voltage coming in. Again, European wound motor really does require that voltage to be at 230, 240 all the time. All right. So we will do a full video for the YouTube channel on replacing a brand new and putting in a brand new switch in a Hummel motor. There's just not time for it here in this setting. So I will go through. This is the housing for the fuse. This is the fuse holder housing. We normally solder these on the wires that are supposed to be on here, and then put these shrink wrap molds around them. Again, this isn't a field fix. This is something that's going to have to happen in the shop. But the only time that we replace these is when they get broken in the field. So something falls on these in the van, maybe a gallon of finish slides off the shelf and falls right down on top of these. That's normally the only time we ever replace these, is if they're broken. They normally don't ever go bad or burn up. But they are sealed, so there's a rubber gasket, and the whole idea is to keep dust out of this compartment. And they actually do a pretty good job of that. You know, we've got it's gasketed here, and keeping that dust out of here, it just increases the life of this, the switch system, and not so much the capacitors because they're sealed, but keeping the dust off of this switch and out of this contactor is key. So let's do, and again, this is just a simple switch, but if anybody's broken one, knows the machine will not start if this is not on. This guy. Okay, so this is the inside of the emergency contact, and you can see that white part there. That's all it does. Engage that, pushes that white piece down, and engages this switch. And that's it. You know, this switch, these wires feed through that up into the motor head here to the contactor. Again, it's just one part of the circuit that allows the voltage to travel through. If it is closed, it runs through, and this is a normally closed switch, and I think it might say NC on it for normally closed, but anyhow, yeah, there it is, NC. So when the switch is engaged, meaning open, no power can travel through it, and it's as simple as that. So a kit comes with the stop button, the switch itself, and the mount for the switch. Really all it is are tabs that pop the switch off, unscrew the mount, screw the new mount on, and I would use the new mount because sometimes these, you know, sometimes the tabs break off, and you know, you want to make sure that the switch is seated. We have this, and it just pops on. You know, it's not a complicated system. It's one screw down in there. So definitely mount the new housing for the switch. And it's just two wires. I mean, we have three coming in. We have a ground, and then 1 and 2. And again, just good wiring practices. Just match it up. If when in doubt, just match it up. take a picture of this stuff with your cell phone before you disengage any wires, so that you know where they go back. And then go ahead and wire it back up. Any questions on that? Nope. Good deal. Again, so we're looking at, in the future, shortly, we will do a whole video on replacing this switch. It should be helpful to any guys that don't have access to a service center. Just remember, use the correct capacitance. I will show you, this is a new capacitor, and we'll dial this over and get you a reading so that you can see it if you couldn't understand it. Or so we're at 124, and plus or minus 10% on the start capacitor. We're fine. No problem there. Now, proper microfarad for the starting capacitor, proper microfarad on the run capacitor, very important. Again, this is what is creating or helping to create that rotating magnetic field that our motor's spinning on. So if we want a proper spinning motor without any vibration, which then would translate to our floor and sander and how it's sanding the floor, then we want to make sure we use the right parts and the right ratings. So anybody has any questions, feel free. If not, I think that's going to do it. Anything else, Angela? No? All good? All right, thanks for joining us. Hope that was a help. Any ideas, let us know. We are certainly open. We just do videos that we think are helpful to you, or that we get questions, a lot of questions or requests for. So you can check out our YouTube channel. Obviously, if you're watching this, you're on Facebook or Instagram or all those social medias. So feel free to email us, call us, cityfloorsupply.com. Have a great day.